Good morning, ladies and gentlemen. Today we're looking at scaling. Now, scaling is the source of the most difficult exam questions, in my opinion, but it's very easy to understand as a concept, I think. Alright, so essentially we're going to look at, and I apologize if you've seen this explanation before, but I keep looking for new ones, but I keep coming back to this. And don't worry, I'll skip the bit about giant spiders. Alright, length. When we blow up a shape, we use something called scale factor. Essentially, if we're going from a length of 1 to a length of 2, our scale factor is 2. So we're taking the small length, multiplying it by the scale factor to get the large length. Easy enough. And we can see that that works along all the edges. So if this edge was 1, it's now 2 high, etc. Alright, what happens with surface area is quite similar. Here, we can see that the scale factor, or the length scale factor, is still 2. However, the surface area in this one here is 1. The surface area here is 4. So if we take the smaller surface area and multiply it by the scale factor, we don't get the bigger surface area, which is quite frustrating. So we can say that the surface area scale factor here is equal to 4. Because if we take the smaller one, which is 1, multiply it by the scale factor, we get the larger one is 4. The scale factor is 4. Note the pattern here, that if we took the original and multiplied it squared, we would get our 4. Watch the pattern here again. The volume of this is 1 times 1 times 1 is 1. The volume of this is 2 times 2 times 2 is 8. So we're looking for some sort of volume scale factor that gets us from 1 to 8. Clearly it's 8. So here, if we're looking at the volume scale factor, it is our ordinary scale factor is 2, but we want to cube it. So here we squared it. What we're saying is that 1 times the ordinary length scale factor of 2 cubed will get us 8. That was meant to be an equal sign. Alright, so when we're using these formulas, I'd like you to focus on trying to find the original scale factor here in this case being 2, and then using it to go between surface area and volume, etc. And I'll show you some examples below. Alright, just to show you it continues working, here the scale factor is 3, meaning we can do 1 times 3, which gets us to 3. So the scale factor going between is 3. However, the surface area on this one is 1, surface area on this one is 9. We can do 1 times 3 squared, which will get us the 9. Volume here is 3 times 3 times 3 equals 27. Volume there is 1. 1 times 3 cubed gets us 27. Note how in each case we're using the same scale factor, but when we're working with surface area, we square it. When we're working with volume, we cube it. Essentially here, if the scale factor is 4, then the area scale factor, or the area, is 16 times larger. Volume 64 times larger, etc. If you don't want to copy that whole table in, then really it's just that line there that's the most important. Alright, so find the volume of the smaller perfume bottle. No, we couldn't actually attempt to calculate it because it's quite an irregular shape. But we can assume they're similar, or we may have been told they're similar. And what we can notice here is that we're going from 6 to 8. So with length, 6 gets multiplied by our scale factor to get 8. And the question is, well, what is 6 times SF? What is SF? Well, SF here is 8 on 6. And if you wanted to find that as a decimal, is 1.33333. I would probably keep using it as 8 on 6. There's no harm in using that as 8 on 6 now. That's meant to be an F. Alright, so the scale factor is 8 on 6 or 4 on 3. They're equivalent fractions. Now, what that means with volume is if we take the small volume, which we don't actually know, if we take the small volume and multiplied it by the scale factor cubed, it would get the large volume. Okay, so it's the same setup as before. The small volume gets multiplied by the surface area Q, scale factor cubed, and you get the large volume. So here we have x times 4 on 3 cubed equals 640. You can reach for your calculator and solve for x. Alright, and we have 270 milliliters. Remember the units. Alright, so here's one from a past exam. Competitors in the intermediate division of the discus use a smaller discus than the one in the senior division, but of a similar shape. Note, similarity question coming up. The total surface area of each discus is given. By what volume can the intermediate discus be multiplied to give the volume of the senior discus? So, by what value can the volume of the intermediate discus be multiplied to give the senior discus? So, what it's saying is that if you have we're talking volume, if we have the intermediate times some value here, it should give the senior. Question is, what's that value? Now we know that that value will be the scale factor cubed. Alright, so now is a question of finding the scale factor and cubing it. Alright, so looking at these two problems, what's happened is 500, and we're working in squares, so centimeters squared, meaning surface area. 500 gets multiplied by the scale factor squared, and that gives us 720. Alright? Now, really, we can find out what the scale factor is then by putting that in our calculator. We can just write in, say, for example, 500. If we don't want to use y again, x again, we can go 500 times y squared equals 720. Y will equal, solve. Y will equal 1.2. And note, the scale factor is unitless, so there's no units here. Alright, so that means that the intermediate discus, when we're looking at volume, intermediate discus, is multiplied by 1.2 cubed to give the senior discus. SENR discus. That's the number thereafter. So we just do the answer cubed, and we have 1.728. Right? 2 marks. Not the easiest thing in a test, or an exam, but doable once you recognize that this scale factor can be used as squared or as cubed, and you don't have to have a pair of lengths to find the scale factor. You can find the scale factor from a pair of total surface areas. Alright, last example, cupcakes. Good multiple choice question. Cafe sells 2 sizes of cupcakes with a similar shape. Nice how they flag the word similar for you, isn't it? Large cupcake is 6 centimeters wide at the base, small cupcake is 4 centimeters wide at the base. The price of the cupcake is proportional to its volume. So here we're going to work in volume. If the large cupcake costs $5.40, then the small cupcake will cost what? Alright, let's find out the scale factor. So here, the scale factor can be found by saying, well, 4 gets multiplied by something to get 6. Turns out the scale factor is 6 on 4, which is the same as 3 on 2, or you can write it as its decimal 1 on 5. Any one of those numbers will work, because they're all the same number. Alright, then we're told it's proportional to the volume, so really we're working in volume here. What that's saying is that the small volume is multiplied by 1.5 cubed to get the large volume. We're not actually working with volume, we're working with cost, so we're told the large one costs $5.40. So then, the question is, well, what is the small volume? Or, in this case, cost. So, small cost, you could just let it be x, and we would have an equation that looks like this. X times 1.5 cubed equals 540. Solve for x. Small cost will equal, give me 1 second, it will equal $1.60. A. Nice. Alright, we'll do lots more in class, but it's about setting this up like that. All right. Thank you very much. Hope you're taking good notes. Bye.